So two dice are being rolled. Which is the equivalent, it's the same thing as saying one dice being rolled one after the other. They don't have anything to do with each other. They're two separate events. Determine the probability of rolling a sum of, and then it gives us a bunch of different options. What a lot of people do when they first approach the statistics of or probability of dice rolling, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Is that they create a table of, okay, so we're rolling two dice. And so here's dice number 1 and here's dice number 2. Now, if we roll 2 ones, then that would give us a sum of 2. If we rolled a 2 and a 1, that would give us a sum of 3. A 3 and a 1 would be a 4. A 4 and a 1 would be a 5. A 5 and a 1 would be a 6. And a 6 and a 1 would be a 7. And it goes up this way as well. And it actually follows a really cool pattern. Like that. So our total sample space, which you can think about, what's the probability of total, or what's the total number of possibilities when you're talking about just rolling one die? Well, it's 6. Well, if you're rolling one die and then another die, that's 6 times 6. So the total number of possibilities is going to be 36, which you can see in this table down here. So a little bit of fundamental counting principle. So the probability of rolling a sum of 2, then you can go through, you can look at the table that you've just created, or you can think about it. There's only one way to roll a 2, which is that both of those die were 1 as they were rolled out. So the probability is there's only one way for that event to occur, and there's a total of 36 possible outcomes. Versus rolling a sum of 3, we have 2 different ways that could occur. We could either first roll a 1 and then a 2, or a 2 and then a 1, and both of those would give us 3. So that'd be 2 out of 36, or 1/18. Rolling a 7 is very likely. It's a very good bet if you're, not that I condone betting, but it's a very good probability that if you pick a 7, that it will be rolled as a 7, because there's a total of 6 out of the possible 36. Probability of 1/6. At least a 9 means that it could be 9, 10, 11, or 12. So that's 4 for 9, and then 3 for 10, making it 7, and then 2 for 11, making it 9, and then 1 for 12, making it a total of 10 different possibilities for this guy out of the 36. And there you go. So that's theoretical, where you say, okay, well, all of these are likely events to happen, and they're equally balanced likely events to happen. And so you have to figure out, well, what are all the possibilities and what are the options that we have for this to happen, versus empirical probability, where they're like, here's a set of information that we gathered for you, and then find the probability, if you picked randomly out of there, find the probability that you would pick somebody that had these certain qualities or whatever. Okay, let's do 2 examples, and then that's it for today. You're dealt a card from a 52 card deck. Determine the probability that you are dealt, and then it gives us a lot of options. So if you are not familiar with decks of cards, I would recommend just really quickly taking a pause, and going onto the internet and looking at decks of cards and seeing what happens. There's 4 different suits: clubs, spades, diamonds, and hearts. You have 2s all the way up to aces, or sometimes aces are below a 2, but it's 2, 3, 4, 5, 6, 7, 8, 9, 10, and then jack, queen, king, and ace. And so there's 1 of each of those numbers and face cards per suit. So if we're talking about the king of spades, there is only 1 king of spades in a deck. And so that would be 1 out of a total possible occurrences of 52. An ace or a jack, there are 4 different aces and 4 different jacks, and they don't overlap. If you pick an ace, there's no way it could be both an ace and a jack. So you have 4 separate occurrences, and if you want this or this, that's a total of 8 different likely happenings out of the 52. A black card would be either a club or a spade. So it's actually half of the deck. Half of the deck is black versus the other half, which is red. And so that would be 26 out of 52, which is half. Not a face card. So everything, and I believe aces are not counted. Yeah, so aces are not face cards. So ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for each of those 4 different suits, you've got 10 that are non-face cards. So a total of 40 out of 52. Okay. You are dealt 3 cards from a deck. Determine the probability that all of them are queens. So the total number of occurrences would be what are the total possible occurrences of any 3 cards being picked out from 52. And there's not a specific order that it needs to be in, but we're picking 3 different random different cards from the deck. So this is a combinations problem. In the denominator, the total number of occurrences is going to be 52, choose 3. Versus in the numerator, what is the probability that those 3 cards are queens? We have a total number of 4 queens. So what's the combination, or what are the probabilities or possible occurrences of 4 cards being picked and all 3 of them are those of a queen? So what are the different ways that you can pull out the queens, right? So we could have a heart, a diamond, and a club, or we could have a club, a diamond, and a spade, right? So there's all these different ways that you can combine the 4 different queens together to make 3 cards. And so when we're talking about total number of a specific event occurring, we just have to narrow our scope. So since there's 4 queens, how many different ways can you pick 3 of those 4? That would go in the numerator. Versus in the denominator, where you're picking from a whole group of 52 cards, how many different ways can you pull together just 3 of any cards? Okay. So we can go ahead and put this into our calculator. We could talk about this in terms of factorial stuff, but we have a calculator, so let's use it. So we'll do combinations of 4, 3, and then divide. Remember that you go to menu and then probability, and then combinations is number 3. And it's going to give us a decimal. Oops. And remember that, or just notice that we are writing all of these as fractions. So just go back in and convert it into a fraction. If you hit menu and go to number and number 2 of that, so menu 2, 2, it says approximate to fraction. And you will get 1 over 5,525. That is a very small probability. Okay, that's the difference between theoretical and empirical probability. It's this idea of what you're looking for over the total number of the sample set that you're pulling from. If you have any questions, please reach out to me. You have all the information you need in order to get started